All right. So it is currently, let's see, let's go ahead and, share my screen. It is currently week 6. So for week 7 will be recursion assignment. So let me just kind of go over what I've kind of got laid out for the rest of the semester. So I've obviously extended the due date for the maze lab. It's not as tough as it seems. You just really got to follow the pseudocode. And if you haven't and check out the video where I've went over it. If you have questions, of course, just ask me today about the specifics. Well, let's go ahead and talk about what we're going to be doing for the rest of the semester. All right. So recursion is our next big kind of tackle. What we're going to be doing is that we are going to be looking at basically this one you'll have I think you should have a bit longer to take a look at. The point about recursion is, and I've got just the due dates for a lot of the stuff, which I'll probably go to do. Recursion's kind of is our next big project. Basically, we have 3, what I would say, big homework assignments throughout the semester, and the other ones are smaller. So you've done the first one, which is the Josephus one, or the solitaire, depending on which one you did. The next one is a recursion assignment. And then the final one will be our cheaters hangman. I was thinking of making a cheaters wordle, but I don't know, that might be a secondary option. The cheaters hangman is pretty well defined and much more cruel than wordle is. So those are the big ones. Your next exam will be on week 11. This is currently week 6. And I don't believe I count, and that's not counting the spring break in there. So that one will go over recursion, trees, and sets and maps and heaps. So everything through sets and maps. Although realistically speaking, with recursion, the recursion will be tested as part of doing your trees. So it's primarily going to be over trees, heaps, and hash maps. Hash maps, for those of you who don't know, are also called associative arrays or dictionaries in other languages, or hash tables. So those are that will be basically our next focus. Once we get past week 11, actually, we start to kind of wind down with. I like to basically hit my peak difficulty kind of in the middle, in like the last 2/3 of the class. And then the last couple of assignments aren't actually going to be, they're going to be more fun and engaging than challenging, if that makes sense, where we're going to do some password cracking and stuff. Like here, you'll notice that we have I have to set the due dates properly, but we'll have this one will have an assignment worth 50 points, which is just do the, which is just simply to make sure you're set up to do the password cracking. Furthermore, once we get to sorting and sorting algorithms, you'll be free to work in any programming language you so choose, which, depending on the problem you're doing, may or may not be nicer for you. So let me go ahead and take, so also, if you've checked your exam grade, don't freak out because it's a 0 currently because I haven't graded it. That's right, everybody failed. No, but seriously, once you turn it in, it gives a grade because it goes through and with the questions that it can auto grade, which for this exam was none. Couldn't auto grade anything. And then the next one was, and then the next exam will have some stuff that will be auto graded. And as a result, it will look like you got a 30 or 40 on your exam when you turn it in. And that leads to, of course, more confusion. If there were any issues with the exam, personally for you, please let me know so that we can try to figure out what went wrong and any way to resolve that. But otherwise, otherwise that's, an individual thing to talk about. Now, the recursion homework gives you 2 puzzles. sorry, is basically you do there's two parts to it, a chess part and Sudoku. They both will use the same kind of super powerful algorithm, which is called recursive backtracking, which I will go over in more detail, which I go over in detail in the videos, I believe, actually. So no need for me really to cover it now. But the idea here is that we've got these problems that can be solved by brute forcing it, except brute force, it kind of refers to the idea of checking every single possible combination that could work, including ones that we would know would be impossible, such as filling an entire row with ones on a Sudoku board. That just doesn't work. You should try stuff. You need to vary your answers up. So basically what we're going to do is that we'll go down we'll brute force, but as soon as we find that an entire branch of solutions is invalid, we will no longer try to attempt that branch. And that's what backtracking with recursion does. It allows us to solve these things much more quickly. So for chess, you'll have the choice of doing either the 8 queens problem, which has been a homework, for computer science and in computer science classrooms since I don't know when, like since computer science was taught in classrooms. Okay, so what I'm saying there is that there are a lot of, solutions you could probably find for this one online. And I just ask that you do the favor to yourself and do your best to avoid those. Because you don't want to rob yourself of the chance of the learning opportunity, right? If you are stuck on this though, please ask me or ask your classmates, right? If you're interested if you've done that problem before, or you've spoiled it for yourself, you might want to try the chance at the Knight's Tour, which is which basically says, hey, it's like one of those games that you sometimes get at restaurants or bars, where basically you want to move your piece around so that it hits every square, but doesn't hit any square more than once, right? So this is given to the challenge by the way that the knight moves, which it moves by jumping in an L space. So this one you may have more success if you start on a smaller board. Both these problems, by the way, are well documented on Wikipedia. So Knight's Tour, right? Knight's Tour right, well documented. This is why Wikipedia is awesome for a lot of computer science stuff. The animations, you just don't get that in other encyclopedias. And there's a couple of different ways to do this. And it says, hey, 8 queens problem, which you want to put 8 queens in a chessboard so that none can capture each other. And the point, and here, exercise in algorithm design is a good example of a simple but non-trivial problem. Simple meaning that it's easy to understand, but non-trivial mean that it's hard to necessarily solve. And that's actually a pretty good idea of the way Sudoku works as well. Sudoku, if you looked it up, we'll go into more detail about that one next week. But Sudoku is interesting because if you generalize Sudoku, it becomes what's called an NP-complete problem. So, and you may have heard that term before, and in layman terms, NP-complete problems are those set of problems that are really, really difficult to solve. We're talking like factorial time to solve, where you have to check all possible combinations, or all possible permutations, all possible combinations, or all possible paths. So something around that runtime, where we're talking about n factorial or worse, takes that amount of time to solve it. But to verify a solution takes kind of a standard polynomial, so O of n or O of n squared time to check if a single solution is correct. So that's kind of one of the distinctive features of these problems. And again, we'll talk in more detail about that. But what's cool about NP-complete problems is that you can take one NP-complete problem and turn them into any other NP-complete problem. It's kind of the big definition there. I have a couple of videos on a playlist on my YouTube channel called Worth Watching. Let me go to my YouTube channel, and I really should link this somewhere on my Canvas page. Let's see. So your videos, playlists. Yeah, I have this video. I have this 7-video playlist called Worth Watching that you can find on my channel. NP versus P versus MP complexity, various things about computer science stuff. Non-Euclidean Minecraft makes stuff weird. So I like computers and games as a kind of an example of non-Euclidean spaces, or experiment or a way to experience non-Euclidean spaces, because playing in those kind of environments and succeeding in them makes you feel very big brain. So, but they're fun, and there's all sorts of tricks that you can do with in game design to make games unique by just incorporating a non-Euclidean element to it. Space not working the way that we assume it's supposed to be working. So that is recursion. Again, I'll go over it in more detail, but there will be more chances for you to tackle that. All right. So any questions before I let you get to work? All right. Hopefully the exam wasn't too bad. We still have some students who have to take the exam. So if you would just refrain from talking about it on the message boards or stuff like that, if you can have whispered conversations with other people, but but again, we've still got people who need to take it either because of scheduling reasons or because the number of messages I've gotten a number of messages over the past couple of days of people saying they've been infected with coronavirus or tested positive. So, if you have the chance, please do get tested if you can. I know it's not exactly the most pleasant process, but it's worthwhile to just have that peace of mind. I certainly have a couple tests racked up because I plan on traveling to see family on spring break. But my father's immunocompromised, so I can't go and visit him if I'm going to test positive. So, do your best to try to I'm sure you might be in a similar situation. So do your best to make sure that you don't spread any diseases to your loved ones.